My name is Dr. Shobhusha Chishen. I am the Dean Research and Development of GIS College of Engineering. But herein I am here to talk about my physics courses. Okay, I am basically a physics teacher. I do take physics in the classes in the BTech courses, so first and second year. So now here I am talking about my second year courses, which is called Physics 2 courses. Now, second year course in Physics 2 is separate for separate branches. For computer science and IT, bouquet is something. For mechanical, civil, it is different. For electrical, electronics, all are different. Obviously, they are learning in a different semester. Now, it is stream specific. It is as per the requirement of your own subject. Okay. Say in the computer science and IT syllabus, we have added the latest computation like quantum computation. Like the applications of latest materials called nanomaterials, how the storage and display devices works. These things are not so much connected with the mechanical and civil engineering, who are also learning physics 2 in this course. So we have kept courses like the ultrasonics, okay, which is applied in mechanical and civil. The concept of building acoustics for civil, which is not needed for you. So basically, we have made it stream specific. We made a thorough analysis of the requirement of your course from your department, from your alumni, from the existing student. We made a survey. Based on that, course objective and outcome was framed, and let me present the same now. Now the course objective of this Physics 2 course for CSE and IT student is to introduce topics, okay, is to apply quantum mechanics for learning the latest of computation called quantum computation, learn quantum logic gates. Is to, as a student, you get comprehend about the hardware sectors of your devices, okay, the storage, display part, and also the latest storage devices. The entire electronics is moving very fast, and that is because of the revolution in semiconductors and now the nano devices. Okay, so an introduction to that. So that will be another objective of this course. And also this entire communication system, okay, it's based on the electromagnetic theory. Okay, so we'll also provide you some glimpses of electromagnetic theory, because later on you have got courses on the analog communication and digital communication. Okay. Now the major course outcome of this Physics 2 course for CSE or IT student is that after undergoing this course, you will be able to explain the electromagnetic theory with your basic knowledge of electrostatics, magnetostatics and electromagnetic theory. You will be able to explain the most modern computing devices using the latest idea of quantum mechanics and quantum mechanics principle. You will be able to explain the operation of the most modern storage devices, how it evolved from the magnetic storage to semiconductor devices. You will be able to judge the requirement of the latest material for the purpose of computing, for the circuit design, and for the storage material, that is the ideas of nanomaterials. Okay, so let us, and this is closely connected with your own program, so you can get that in the course outcome, program outcome mapping also. On the screen you can see the various modules that are present in this course, and you can also see the module that you will be starting with. We'll start with one of the promising modules of the course, as well as you can also see the topic that we will begin with. And in this particular class, whatever we will be focusing on, the related prerequisite, what is the objective of the class, and if at the end of the class you're supposed to get something from me, that is the outcome of the session. So that session outcome also you can see on the screen. Hello and welcome to class 6 of my class of Physics 2 and also Quantum Mechanics 2. That is your first chapter in your Physics 2 courses, and I have been telling you that the main focus of this Physics 2 course is to give you some more insight about the physical science and physical science essence of something that you are learning in your own computer science or information technology courses. We are offering the quantum mechanics 2, which is the foundation of many important things. The quantum computation, the latest computation. You must have heard about quantum computer by this time, because I have already told it. By this time I request you to explore Google, because it has come up with quantum computer, get it the essence, how important it is, how efficient it is, and you will be learning, you will be designing, you will be working in Google
to design a quantum computer of sometime. So as a physics teacher, my first job is to introduce you with the word quantum, with the techniques of quantum mechanics too, and the basics of quantum computation. You learn it. We'll talk about various semiconductor devices, nano devices. So all these things need a profound knowledge of quantum mechanics too. That is something that I have been trying to offer in the course of my last few lectures. So let me make a small summary as I everyday do in this sixth lecture. The is myself. That you should not the focal point or the starting point of our class is this issue, that in this class we only show all interest on wave nature of matter, and matter can show material nature, example collision. Wave can show wave nature, example superposition. Wave can show particle nature, example photoelectric Compton effect, and matter can show wave nature, example Davison-Germer experiment. You know it. This wave is called matter wave. This wave is a mathematical wave. It is a probability wave, as I told you. Electron, if it collides, it is a matter electron. We have got no interest on that in this class, because that is something you know. How two matters collide, classical physics has told you how to discuss that. We are interested about this issue. Electron is not a matter electron. It's showing the wavy nature, wavy property of the electron. That is something we are focusing on that. Electron is a wave. So it's a wave of what? I am not the first, let us correct the word. Electron is not a wave. Electron is a matter. It is defined with some mass, some charge. The quantum mechanics tells electron can show the property of the wave. That is it has done in the Davison-Germer experiment. So it's a wave of probability. It's which type of wave? Electron can show the property of superposition, interference, which it did in Davison-Germer experiment, and which is used to explain many phenomena of nanoelectronics. Okay, we will learn it later on, the interference of electron waves. You have studied in chemistry superposition of S wave and P wave of electron, hybridization. So it's a superposition of whom? Not the matter electron, the probability waves of electron. I have been telling you, it is at a given point, is the electron moves, you cannot see the electron, you take chances to find out the electron, chances to vary at that point, as I have shown by the arrowhead. There any variation, any fluctuation makes waves. It's a wave of chances. Every day I will remind you, okay, that it's a wave of probability that we talk about. Probability is just like the S wave, P waves of electron. You know it. These are common pictures to you now. And this wavy parameter is described by the mathematical function psi with psi square, giving the probability of finding the object. In a problem of quantum mechanics, therefore getting psi is the most difficult job, and or the start first job, and that you can do for any problem of quantum mechanics. Any suppose it's it's a problem where a single particle is moving, a single electron is moving in this problem. Okay, so for this type of problem, how do I describe the problem? First thing I have to know is wave function. That is the wavy nature of the matter is described by that mathematical function. So how do you get that function? Any function is obtained by solving any corresponding differential equation. In this case, psi is obtained by solving the equation of Schrodinger, where h cat means Planck constant by 2 pi, 2 is a constant, m is mass, psi is the function, v is potential energy, I is root over -1. From problem to problem, V will vary because V is the potential energy term. It will vary. If no force is there, it will be 0. Some force is there, it will be non-zero. And it's a Schrodinger equation. And if you have to solve it in a problem, you have to use some more mathematics. You have to use a technique called separation of variable. If you use separation of variable, you will see the separation of variable. It is a beautiful technique. It separates the equation of Schrodinger. That is at the top, original time dependent equation. I have separated this into two parts, time part and space part. So these are the beauties of this for physics and mathematics together. If they come in together, it makes so much wonderful thing. And that last equation is something that you have to concern from problem to problem. Now what I tried to illustrate is that another beauty of mathematics. Okay, psi is a function. How it can give me physical information? I reminded you then the basic definition of motion. Any motion is described by knowing some physical parameter. So fundamentally, you wish to know position against the variation of time, and that will tell me how the change in the all the problems, how position changes with time. That defines the degree of the change in the problem. Okay, how it differs from one problem to another problem. You see the motion of pendulum, motion of spring, that will illustrate it. Okay, motion of train, all these are example of mechanics problem. And to describe any problem, all these variety of problem, train may collide, train may fall down, many things can happen. This any body can slide down, any objects can collide. So all these are dynamics problem. To describe any dynamical problem, you need to measure some physical data. All those variables together are called dynamical variables. So the question is that for a big object, train, bus, car, pendulum, you can measure it because they are object. This object are large object. But in a quantum mechanics class, we talk about electrons. Here, 3 electrons are moving together, but I cannot see the electron, so I have to get the all. But electron is moving. It has got momentum. It has got kinetic energy. So, and to me, electron is just a function psi. So I told you that we have to adapt a technique so that from psi we can generate all these data. Okay, all these data can be obtained from psi, and psi is a function. So if you have to, the technique is that you have to talk with psi. Because it's a mathematical function, you talk with psi in its own language, and that language is an indirect method called the language of loop operator. Okay, so what would happen? Any variable you wish to measure, operator means mathematical operator. Okay, so there will be a corresponding mathematical operation, and these are the list of operators that you can see on the screen for every. It's a very beautiful table. Okay, list of variables are there. How do you see them classically, and how do they differ quantum mechanically? That is presented. For every variable there exists an operator. If you put a classical symbol with a cap, it makes a quantum operator. X become x cap, that is position. Time t becomes t cap. Momentum becomes p cap. Okay, Hamiltonian becomes h cap. Kinetic energy will become t cap. Hamiltonian means t plus v. Potential energy, so there v becomes vx cap. V is a function of x, and any energy becomes E cap. And I requested you to remember the operator form of momentum. It is minus h car del X, and operator position and time do not change. I told you, if you remember these two, you can calculate kinetic energy, because everybody knows from school day, kinetic energy is half mass into velocity square. So if you multiply it with m in the numerator and denominator, it becomes p square by 2m. So if you put the operator form p, then it becomes the expression like that, minus h square by 2m d2 dx2. So potential energy is a function of x. X does not change, so potential energy does not change. Hamiltonian kinetic plus potential energy makes the total energy. So summation of minus h square by 2m d2 dx2 plus vx. So these are basically they have been doing some mathematical operation, derivatives basically. And energy means time dependent operator, ih got plus h cos del t. So the mantra is that you have to remember that position and time do not change, as it happened classically also. I do not use different formula to measure position and time of an object. We measure them directly. Okay, and you have to remember the formula momentum minus h cut del x. If you remember these two, next three will follow. P square by 2m will give you kinetic energy. V x does not change. Potential is a function of x, so V does not change. Hamiltonian is a summation of T and V, and energy is that much. So after that, last day actually, I told you how do you what is the response of psi. Okay, how psi responds to give this physical data, because these are only formula of getting the function. If I have to get momentum, I have to talk with psi. So I have to operate the operator of p on psi. So what is the response of psi, that you have to tell. So p will act on psi. So that I told you last day that if I have got any, suppose two problems. First problem is an electron moving. Suppose this wave function, this is the same problem I did last day. Is wave function. I have solved Schrodinger equation. It is a sine kx. I wish to know two data, t and momentum and kinetic energy. So who knows this data? Psi knows this. Act psi. So operator of momentum will act on psi 1 and kinetic energy will act on psi 1. So in the first case, if p operates on psi 1, you are doing a first derivative of sine. So it becomes minus h cut k, and if the sine becomes cos with a k in front. So minus h cut means h by 2 pi and cos function. And for kinetic energy, you have to do double derivative. So sine will become cos, and cos to sine with the minus k square. So it becomes like minus t psi 1 equal to h cut square k square by 2m and the sine function. So if an operator t acting on a function sine gives you back the function sine, that means you are satisfying eigenvalue equation, and then sine function becomes eigenfunction of t cap. The constant h cut square k square by 2m, or as I have written h cos k square by 8 pi square, because h cut is Planck constant by 2 pi. then it is the eigenvalue. That is the eigenvalue or the measured kinetic energy of the object. Okay, so sine function is an eigenfunction of t cap, but not the eigenfunction of p cap. We utilize this idea in the case of kinetic energy operator. In the next case, where suppose I have solved Schrodinger equation, I consider my wave function is e to the power plus ikx. I wish to get two data again, momentum and kinetic energy. So operator of momentum should act on psi1, and it has acted. You can see that. Okay, h by 2 pi, and you have got h cut k, that is h cut means h by 2 pi and e to the power function back, because if you differentiate e to the power function, e to the power ikx, it gives you ik and e to the power function back. For kinetic energy, ik square and e to the power function back. So in both the cases, we are getting back the function, so satisfy eigenvalue equation. So this wave function, e to the power function becomes eigenfunction of both t cap and p cap. The idea is that you have to satisfy the eigenvalue equation. Eigenvalue equation means operator will act on the function, will give you the function back multiplied with a constant. Okay, then and only then you can measure, otherwise from this I get two more ideas. Okay, the idea of the Hermitian operator, because when you measure, four cases are there. When you measure, you see, when you can't measure, there is an imaginary term minus h cut. But if you can't, if you do measure, like h cut square k square by 2m or h cut k, these are all real value. So if you do measure the constant, the measured value or the eigenvalue is a real quantity. So the operators in quantum mechanics called Hermitian operator. Okay, so with operators we have to tell something more actually. So that I shall do now. I'll be talking a bit more information, sharing you a bit more information. I have given a home assignment. I have done it for e to the power plus ikx. I ask you to do it for e to the power minus ikx. Okay, so let me do it, keep both the problems in front of you. Something new is waiting for you. Okay, just let us see. Okay, this problem will be coming. Okay, it is a concept of eigenvalue, eigenfunction will be utilized there. So let me do it quickly. This problem I did yesterday. Okay, the operator e to the power I, suppose this is the electron moving, it's a function. I solve Schrodinger equation. This is my function. So if you have to know momentum and kinetic energy, momentum operator will act on psi2. So e to the power ikx, if it acts, this gives you this much. P psi2 is equal to minus h cut and minus ik will make it a plus h cut k and e to the power function back. So you satisfy eigenvalue equation as I told you few minutes back also. So in this case, if you do double differentiate, you get ik square. So this makes h cut square. It was like k square was not there initially. H cut square k square by 2m and psi2 back. So the both of them are satisfying this general equation. Operator O acting on the function gives you back the function multiplied with the constant. This is the general structure of eigenvalue equation. So in both the cases it is satisfied. This is the eigenvalue. So psi2 is an eigenfunction of p cap and this is the eigenfunction of p cap also. In the next case, that was your home task I asked you to do. So if you do it, it is p psi2 minus h cut. If you take the derivative, it is minus ik and e to the power function back. In this case, t psi2 minus h cut square by 2m minus ik square a e to the power minus ikx. So if you do it, it becomes this much h, this minus minus plus. Okay, you can see here minus ih cut del x and minus ik is coming, so it becomes minus minus a plus I minus 1. So it becomes p psi2 equal to minus h cut k and you are getting psi2 back. So you see it is also an eigenvalue equation, but if you compare with this case, it is positive plus hk, it is minus h cut k. So if in this first case electron is moving along positive x direction, if this is the momentum, in this case electron is moving in the minus x direction because it is minus h cut k. Okay, so that is the difference between the two problem. And in this case kinetic energy value, if you measure it, it is becoming like this much. Okay, t psi2 equal to h cut square k square by 2m and psi 2 back. So it also satisfy an eigenvalue equation in this case. Okay. Now the beauty is that suppose I have taken a mixture of these two. I have taken a mixture of these two functions. Okay, I have taken a mixture of these two functions. Okay, e to the power of ikx is therefore e to the power plus ikx is satisfying eigenvalue equation, or it is an eigenfunction of t cap and also the eigenfunction of p cap. And e to the power minus ikx also, if you check here also, it is an eigenfunction of t cap and it is also the eigenfunction of p cap. Now suppose I have taken a mixture of the two, then what would happen? If I take a mixture of the two, suppose this is my mixed wave function, okay, the operator psi, this is a mixture of these two, e to the power plus ikx and e to the power minus ikx are mixed here. C and D are this is called linear combination of the two functions. I have taken linear combination of both the functions. So if I do so, now my question is that if this is the wave function of the electron, and I wish to know two data, what is the electron momentum and electron kinetic energy. Who knows this data? Psi knows it. So operate T on psi. If you operate T on psi, you get minus h cut square by 2m, and if you do differentiation, okay, d2 dx2 will be there. Double derivative of this quantity, double derivative of this quantity t psi is equal to minus h cut square by 2m. If you take a double derivative of this will give you ik square c to the power ikx, and the next one will give you minus ik square d to the power minus ikx. So this will become ik square will give you minus k square, and this is also minus square is plus, this is also going giving you minus k square. So it will be taken common outside. So t psi equal to h cut square k square by 2m, and it will become same function back, c to the power ikx plus d to the power minus ikx. So you see t psi is therefore is equal to h cut square k square by 2m, and this is nothing but psi. So you please see this is also an eigenvalue equation of the same kinetic energy operator. Okay, and this is again the measured value or eigenvalue of the same kinetic energy operator, and this is the eigenfunction of the same kinetic energy operator. So the message is that you please see here, if I have got electrons moving, this if the wave function of the electron is e to the power plus ikx, and if I wish to measure kinetic energy of the electron, I will operate T on psi 2. If you do operate, it satisfies eigenvalue equation h cut square k square by 2m and psi 2. So this psi 2 becomes an eigenfunction of the operator of kinetic energy. In this case, if you operate T on psi 3, you are also satisfying the same kinetic energy value. Okay, and the same kind, it is also eigenvalue equation. So psi 3 is also the eigenfunction of t cap. Now the idea is that if you take a linear combination of these two, as I have done just now, say this is psi 4 or just psi I have taken. So this is also satisfying in the eigenvalue equation with the same eigenvalue, because I have told you that is just a structure. So that means the psi, which is a linear combination of these two, is also an eigenfunction of the same operator. So the idea is that if individual function e to the power plus ikx and e to the power minus ikx are eigenfunction of an operator t, their linear combination, their mixture is also the eigenfunction of the same operator. So what I am trying to tell you is this much: if e to the power plus ikx is an eigenfunction of kinetic energy operator. If e to the power minus ikx is an eigenfunction of the kinetic energy operator. Now if you take a linear combination of these two, c to the power ikx plus d to the power minus ikx, this is linear combination of these two. Suppose this is psi 1 and suppose this is psi 2, this is psi 3 according to my description. So this will be like c1 psi 2 plus C2 psi 3, because these coefficients will be giving a new constant. So this is called linear combination of the initial function. Linear combination of psi 2 and psi 3. You see this linear combination is, which is called psi here, that is also satisfying, that is also becoming eigenfunction of the kinetic energy operator. So if individual functions are the eigenfunction of an operator, their linear combination is also eigenfunction of the same kinetic energy operator. Now this is one of the theorem of physics. Okay, if psi 2 is an eigenfunction of that operator, psi 3 is an eigenfunction of that operator, then their linear combination c1 psi 2 plus c2 psi 3, or maybe this much, this will also be the eigenfunction of the same operator. So their linear combination is also the eigenfunction of the same operator, is also the eigenfunction of the same operator. Okay, that is something, that is what I am trying to tell you. So if you don't understand it, I repeat it, that if I have got a function, say psi 2 is equal to a to the power ikx, is eigenfunction of an operator t cap. Okay, psi 3 is equal to a to the power minus ikx is an eigenfunction of the, say, of the operator t cap. Then if I take psi is equal to c1 psi o2 plus c2 psi 3, then this will be also eigenfunction of the same operator. So this is actually one of the theorem of physics. This is called, you see what is this? This is the linear combination or superposition of psi 2 and psi 3. Linear combination of psi 2 and psi 3, or you may say this is the superposition of psi 2 and psi 3. So if individual functions are eigenfunction of an operator, their superposition is also the eigenfunction of the same operator. So in literature, this is called superposition principle. This is called superposition principle in literature. Okay. Now superposition principle is an extremely important idea of quantum mechanics. Based on this, entire quantum computation is based on this idea. It is relying on this idea. It is very simple. If individual functions are eigenfunction of an operator, then their linear combination will also be the eigenfunction of the same operator. I have done it for two psis, but you may generalize it. Okay, you can write down it. If I have got, say, n number of psis, and for any operator O, if it is an eigenfunction, it is satisfying an equation like this: a1 psi 1. Suppose I have got another psi with the operator O, it is satisfying an equation a2 psi 2. I have got another psi with is satisfying an equation a3 psi 3. I have got another psi, it is satisfying an equation like this much a4 psi 4. Similarly, I have got another psi n, it is satisfying an equation on psi n. If that is the story, then if I take a linear combination of all these psis, if I take linear combination of all these psis, linear combination of all these psis, that is psi is equal to c1 psi 1 plus c2 psi 2 plus c3 psi 3 plus c4 psi 4 and so on up to cn psi n. If I take a linear combination of all these psis, then this is also going to be the eigenfunction of the same operator. Okay, this is called superposition theorem in quantum mechanics. Superposition principle in quantum mechanics. Okay. Now in this equation, I can write down it in this way. The psi can therefore be written in this way. You see, summation over I equal to 1 to n ci psi I. At I1 means first term, I2 means second term, I3 means third term, and summation means they will be added up. Now this Ci is called coefficient of linear expansion. This is called coefficient of linear expansion, and psi I is obviously the in the individual eigenfunction or eigenstates they call it. Now in a real problem, okay, this CII is calculated from a very important concept, okay. But before that, I have got another job to tell you what is the meaning, importance of the superposition principle. Importance of superposition principle is enormous. Okay, it is used in quantum computation. Okay, what is the meaning of superposition principle? If individual functions, suppose I have got one function psi1 is indicated by a state 0, it's a wave function, okay, quantum mechanically, and psi2 just like classical 0 and 1, this is another, it will be another wave function. When we'll be learning quantum computation later on, you'll realize, okay. So it tells us if I take a linear combination of these two, c1 psi1 plus c2 psi2, that is c1 0 plus c2 1, okay, this will also be an accept this, okay, this will be an accepted wave function. Now in quantum computation, this means a quantum bit, this means a quantum bit, so that means this combination will also be a quantum bit. So this gives an option that number of quantum bits are enormously high. There is a condition is there that mod c1 square plus mod c2 square be equal to 1. So that is a major difference with the classical computation. Number of binary digit is only 2, but number of quantum bit is enormously high. Okay, these are the number of bits. Number of quantum bits, it's enormously large. Okay, now this is one of the advantage of quantum computation, okay, which I will be discussing this later on, and this is entire thing is relying on the idea, and this idea that total probability is equal to 1. So many things are waiting for you. You have to wait for a few days for that discussion and deduction. I will do that, but just again you get back to, okay, so this is a very important idea. In actually say 0 means equal, this is a wave function, so it's a quantum mechanical state. Suppose this is spin up state and this may be spin down states, okay. So spin up and down state are represented by, just think what we do in quantum computation. This is spin, you are directly dealing with spin of an electron. It is not like the high and low voltage states of classical computation or normal binary system. You have to work in the low dimension at the level of atoms. Electrons spin up and down. Just think the level of work people have to do if you have to work in the latest device. So level of knowledge you need, okay. The beauty is that if spins up state is an allowed function, down is an allowed wave function, which all of you know. Now the mixture of these two is also an allowed wave function. How is it possible? Because spin up state means electrons magnetic state. Suppose this represents a magnet like this. Spin down state means another magnet like this. So that means it will be another magnetic state of the, it is a mixed magnetic state of the electron, okay, mixed state of the electron. Okay, it can be attained. We'll discuss that in quantum computation class, but you see it's a very funny area working here. So superposition principle is very important, okay. So take it very seriously. We will discuss it later on, but I'll just ask you to that idea, okay, that you let me get back to the superposition principle, that expression that if psi1 is an eigenfunction of an OCAP, psi2 is an eigenfunction of an OCAP, psi3 is an eigenfunction of an OCAP, psi4 is an eigenfunction of, just like psi-n is an eigenfunction of any operator OCAP, then their linear combination, that is c1 psi1 plus c2 psi2 plus c3 psi3 so on up to cn psi-n is also becoming the eigenfunction of the same operator. That is the message, okay. So everybody is satisfying this equation, okay, all the functions are satisfying this equation. It is satisfying an eigenvalue equation, this is satisfying an eigenvalue equation, okay, everybody is satisfying an eigenvalue equation like this. So I ask you to look at this equation. I can write down this in this way: I equal to 1 to n ci psi I. Now this is CI is another important idea. As I told you, it is called coefficient of linear expansion. Now, how do you get this coefficient of linear expansion is another important idea. Now, this is obtained from another beautiful concept of mathematics, that is called orthogonality condition. Again, mathematics. In examination, problems do appear of orthogonality condition calculation. So, let me talk about a bit about this orthogonality condition. What is orthogonality condition? What is orthogonality condition? Let me just share you that. Of any two functions, psi mx and psi nx is given by this much. It is given by this much. Integration minus infinity to plus infinity psi m star x psi nx dx, where psi m star is called complex conjugate of the function. Now it tells us you will get zero result if m is not equal to n, and you will get one or non-zero result if m is equal to n. Now this is going to be one of the workhorse of when we'll be solving any further problem in quantum mechanics. So we need a little bit of more discussion in the line of orthogonality condition. So I think I shall discuss in the next class. Okay. So before that, let me just make a quick recap of whatever I told you till now. Okay, just get back to this picture again. So we have talked with Shai. Okay, so the concept of this is superposition principle. You please see, I have just written whatever I told you, that this is a, so if I have allowed states are Shai 1, Shai 2, Shai 3, etc. Their mixture is also an allowed state. You see, this is beautiful. Okay, the matters, these are two psi 1, psi 2, psi 3. Each ball matter means one psi. Okay, one psi is coming. Okay, just try to see the animation. Each one is a psi, so they are superposing. Okay, you see now they are superposing. Okay, much like the diffraction pattern. You see, this is superposition. You see that another animation there. Okay, now you see this is the concept of zeros and ones that I told you. Quantum bits, there are two zeros and one. Zero is a quantum mechanical state, maybe spin up state. One is another quantum mechanical state, maybe spin down state. Okay, classically speaking, you get either 0 or 1, but quantum mechanically, you see the animation, beautiful animation, either 0 or 1. Okay, in classical physics, but quantum mechanically, each combination of 0 and 1 is giving you funnier things. It may be elephant, it may be a cat, it may be a parrot, it may be elephant, it may be a peacock, or it may be a pig. What does it mean? That means they are not allowed state, acceptable state. Okay, it's a beautiful animation. Okay, that crying means 0, and happiness is that with spectacle 1. Classical physics means you get either you cry or you smile. Quantum mechanically, in between, all options are there. All options are there, like that. All the animals that are shown, that is the quantum states. Beautiful animation. Okay, please spend some time about this. Okay, you'll realize. Okay, beautiful animation. So classically, high and low means high voltage state, low voltage state. Quantum mechanically, classically high means happiness, sadness. So apart from that, nothing can happen. But quantum mechanically, apart from being happy and sad, you can get all other things. You can be all those wonderful mindset you can develop, just like that. Here also, apart from binary means zeros and one, high and low. But in quantum bits, these are all quantum mechanical state. Apart from 0 and 1, there are so many options are there. Okay, you can see this is a qubit. You see 0 means upspin state, down 1 means downspin state, and all their mixtures. You see the combination is changing. Okay, and that, okay, circulating current will produce magnetic field. One direction of magnetic field is the, just see the picture. Okay, so the electron, how magnetism is developed through Biot-Savart, according to Biot-Savart law. If current flows in a circuit, you will get a axial magnetic field. If magnetic field direction is in the clockwise sense, there will be one direction of the magnetic field axially, and if the current flows in another, current flow in clockwise say suppose the magnetic field direction is downward and in current flows in anti-clockwise phase, so where the current magnetic field direction is upward. Upward may be one state, downward may be zero state. So quantum mechanically speaking, in between superposed, zero is a quantum mechanical state, one is another quantum mechanical state. See the left hand side picture, okay? So zero down means zero, the clockwise current means down spin states, okay? Zero, that is zero. Anti-clockwise current means up spin state, okay? That is one. Quantum mechanics tells us their mixtures are also allowed, okay? I hope you understand, okay? You see the right hand side picture also, all intermediate state, all the fractions are changing, all those mod c's, coefficients actually c's, okay? Mod c squares, okay? The percentage is changing, the total probability will be 1. Apart from 1 and 0, see the right hand side 0, 1, and all the mixtures are allowed. So these are the variety of quantum basic conjunction. Beautiful topic, okay? So now I end up today, but related to automatic condition, I need a lot of discussion. I will do that in the next class. Thank you. See you again.